मैंने मैसेज तो ड्रॉप कर दिया, अब देखो कब तक आता है।
चलो चलो फिर ना हम शुरू करते हैं। डिफाइन सॉरी डिफाइन पावर। अच्छा, so we mentioned this yesterday as well. So when usually the first question, it like gives you a glimpse of what the whole question is going to be about. So if the first question is asking about power, that means the whole question is going to be around work, energy, and power. So basically, uh, you can on always work out the definitions from the formula. E is equal to work done over time. So if anything is being divided by time, you can call it the rate of change. So or rate of so you can say power is work done per unit time. Consider that's basically what this power is. Use the definition of power to show that the SI base units of power are kg meter square per second cube. So in the equation which we just wrote, work done over time, and work done is basically force into distance. What's force? Force is equal to mass into acceleration, and mass is kg. Acceleration is meter per second square, as since acceleration is change in velocity over time, so meter per second, that becomes meter per second square. So force we get kg meter per second square, and if you put that in work done, we get kg meter per second square into meter. So work done becomes kg meter square per second square, and now we divide it by time. So power is basically kg meter square second square divided by time, which is seconds. Since seconds is being divided by time, you can take it over there and you can say it's basically 2s power minus 1. That will add. So you get kg meter square per second cube. The intensity I of a sound wave moving through a gas is given by frequency square, amplitude square, velocity, and k, where k is a constant that depends on the gas. Determine the SI base units of k. So basically, this is another homogenetic question, and these are very easy formula. So, intensity, basically, intensity is power over area. That we do it in waves. Basically, the magnitude of power over a applied area. So power, we just figured it out. It was kg meter square second cube divided by area. Area is meter square. So meter square cancels out. So we left with kg per second cube. That's intensity. Frequency. Frequency is basically 1 over time. The period of a wave. This is the amount of uh, number of waves per unit time. So it's basically 1 over second or second negative. So s per second square, and amplitude is basically it's the distance of the wave, right? So we can say amplitude is in meters. So into amplitude square meter square into velocity, it is meter per second, and into K. Now we just need to simplify this. Let's just take all of those units on the other side of the equation. K is equal to kg per second cube. Let's just take it over the downwards to the denominator. Kg second cube into m meter square was being multiplied, so it will divide meter square. And over, so let's write this as meter per second. So this will multiply on that side second, and that meter will also multiply, sorry, divide over this side. And this we can write this as uh, it's basically per second square. So 1 over second square. So this multiplies over here per second square. This cancels out. This will add to become second cube. This cancels out as well. So what we're left with is kg per meter cube.
यो अस्सलाम वालेकुम।
वालेकुम सलाम अली, क्या हाल है? A rigid uniform beam of weight W is connected to a fixed support by a hinge as shown in figure 2.1. A compressed spring exerts a total force of 8.2 Newton vertically upwards on the horizontal beam. Spring exerts a total force of 8.2. A block of weight 0.3 Newton rests on the beam. The right hand end of the beam is connected to the ground by a string at an angle of 30 degrees. The horizontal tension in the spring is 4.8 Newton. Distances along the beam are shown in figure 2.1. The beam is in equilibrium. Assume that the hinge is frictionless, so there is no force over here.
वैसे ये वाला क्वेश्चन बहुत सिमिलर है मैथ्स के M1 के साथ।
यार
P4।
उसमें उसमें बेसिकली वो तो इक्विलिब्रियम के वो एक ही फोर्स होता है ना, उसमें लग रहा होता है। हाँ,
हाँ,
सिमिलर है, कह लो।
तो उसको यूज़ कर सकते हैं यहाँ पर।
हाँ, बेसिक वहाँ पे वैसे मोमेंट्स नहीं होता, ये तो मोमेंट्स है। वहाँ पे बेसिकली इक्विलिब्रियम होता है। वो रेजोल्यू
हम्म।
इसमें भी रेजोल्यूशन है। हम रेजोल्यूट रेजोल्यूट करते हैं हमने इसको। बट यहाँ पे मोमेंट इसमें आता है, वहाँ पे मोमेंट का तो मैंने अभी तक नहीं देखा, मैंने नहीं कहा मोमेंट है M1 में। इक्विलिब्रियम क्या है? इक्विलिब्रियम फोर्स के इक्वल कट होता है। अच्छा, show that the vertical component of the tension in the string is 2.4 Newton. Oh, this is easy. For this is tension, and they've given us this angle. So what we just do is uh, this component with the angle is always cos theta. So this becomes t cos theta, and this component will be t sine theta. The vertical component will be 4.8 sine 30, which is 2.4 Newton. By taking moments about the hinge, determine the weight W of the beam. Okay, so know that clockwise moments equal to anti-clockwise moments. So the clockwise moments which we have are firstly the tension 2.4 into 0.5 plus 0.1, 0.6, 0.8, 1.2. 1.2 plus weight also is in the clockwise direction. So the weight of this uh, there was a weight of 0.3 Newton. It's set a distance of 0.8, 0.5 plus 0.27. 0.8 into it gives us 0.3 Newton plus the weight of the beam 0.6 meters away, 0.6 W. I think we finish with the clockwise moments. So the only anti-clockwise moment which we have is this spring right here, and it has a force of 8.2 Newton into is at a distance of 0.5 meter. Basically, we need to simplify now. We calculate W. W we get is 1.6. Calculate the
अगला
horizontal comp. Really?
तुम्हारा भी ट्यूसडे को है ना 29 अप्रैल प्रैक्टिकल फिजिक्स का?
नहीं ब्रो, मेरा 2 4 3 4 है मेरा।
किस दिन है?
मैं 3 4 वेरिएंट है मेरा, लाइक एंड में एंड पे है।
अच्छा अच्छा। वरना मैं पूछने लगा था कि तुम्हारा क्या आइडिया है कि तुम्हारे प्रैक्टिकल में क्या आएगा।
इलेक्ट्रिसिटी आ रहा है, इलेक्ट्रिसिटी।
हमारा
और
भी ये लग रहा है कि ये इलेक्ट्रिसिटी और क्या कहते हैं ये
आपका
वाटर रिलेटेड जो होते हैं।
आपका वेरिएंट 3 3 है ना?
मेरे ख्याल से 3 3 है क्योंकि मेरा 29 अप्रैल को हो रहा है।
हाँ, तो इसमें इलेक्ट्रिसिटी 100% आ रहा है, सेम ही पेपर है हमारा।
हाँ
99%। अच्छा, बाकी लाइक कैलकुलेट द हॉरिजॉन्टल कंपोनेंट ऑफ द फोर्स exerted on the beam by the four. Okay. So basically, we know that the horizontal force, we calculated the vertical forces over here. So now we know that there is also a horizontal force acting on the beam, which is over this tension right here, T cos theta. So this will put an equal but opposite force since it's stationary. So it will be equal to T cos theta, 4.8 cos 30 to 4.2. The spring obeys Hooke's law and has an elastic potential energy of 0.32 joules. Calculate the compression of the spring. Elastic potential energy has many formulas like half KE, or you can also say uh, half FE, sorry, half KE squared, or half F squared over K. So we have the energy, and we need to find the compression, which is extension, and we have the force. So we'll use this one. 0.32 joules is equal to half into force, which is 0.8 to compression or extension. So extension you get is 0.078 meter to 6 The string is cut so that the spring extends upwards. This causes the beam to rotate and launch the block into the air. Oh, big shot. The block reaches its maximum height and then falls back to the ground. Figure 2.2 shows part of the path of the block in the air shortly before it hits the horizontal ground. The block is at a height of 0.09 meter above the ground when it passes through point A. The block has a kinetic energy of 0.044 joules when it hits the ground at point B. Its resistance is negligible. Calculate the decrease in gravitational potential energy of the block for its movement from A to B. So decrease in, or you can say, okay. So initially it's saying decrease, so we can just do initial minus final to get positive. Initially the block has a weight of 0.3 Newton. So GPE to weight into gravity, right? MGH, sorry, weight into height. So initially we have 0.3 into 0.09, and uh, at B it basically does not have any gravitational energy. So we can just, this is basically the change, is 0.027 joules. Use your answer in C part for in conservation of energy to determine the speed of the block at point A. Now this is similar to the questions in M4 or M1, sorry, in maths papers. So we know that change in energy is equal to change in work done. So basically, since A is negligible, so we can say that change in GPE equal to change in kinetic energy. So we know that the change in GPE is 0.027 joules. And B, it has a kinetic energy of 0.44 joules. So you can say that the kinetic energy basically half m v square. So the change, so basically at this point, kinetic energy will be, since all of the GPE has converted over there into kinetic energy, so at A, kinetic energy will be 0.044 minus 0.027, which is 0.017. So at A, the kinetic energy is 0.017. So we can now put this into the equation. 0.017 is equal to half m, where m is 0.309.81. Since W is equal to mg, m is equal to W over G, so half m v squared. And from here, you get V is equal to 1.1 meter per second. By reference to the force on the block, explain why the horizontal component of the velocity of the block remains constant as it moves from A to B. Basically, the component of velocity over here is same as what which is over here, same as over here. So basically, velocity will only change if there is acceleration, and there is acceleration only when there is a resultant force. However, you can see that in the horizontal plane, there is no force acting on the block. There is only a vertical force, which is gravity. So we can say that uh, there is only gravitational force. Is what, that's why the horizontal component velocity remains constant. The block passes through point A at time ta and arrives at point B at time tb. On figure 2.0, we sketch a graph to show the variation of the magnitude of the vertical component of the velocity of the block at time t. Numerical value of y. So we know at a there is some speed, so we'll start somewhere above zero, and the variation of the vertical component of velocity changes when there's acceleration, and the acceleration over here is 9.81, which is constant. So there will be constant change in velocity, i.e. it will be a straight line. Yes. A block is pulled in a straight line along a rough horizontal surface by varying force x, as shown in figure 3.1. A resistance is negligible. Assume that the frictional force exerted on the block by the surface is constant and has magnitude 2 Newton. Basically, we have frictional force of 2 Newton. Variation with time t of the momentum p of the block is shown in figure 3.2. That momentum increases from 0 to 4 in 4 seconds. Sorry, to 6 in 4 seconds, and then on. State Newton's second law of motion. Newton's second law of motion is resultant force is proportional to basically resultant force is equal to change in momentum over time. So resultant force is equal to the rate of change of momentum. Use figure 3.2 to determine for the block at time t is equal to 2 seconds the magnitude of the resultant force on the block. So the magnitude of the resultant force is same throughout this time. So we can calculate this resultant force equal to change in momentum. Change in momentum is 6. Time it took is 4 seconds. So it's basically 1.5. The force X. Since there is a resultant force of 1.5, that means X minus 2. I'm gonna take what here. X minus 2 is equal to 1.5. So X we get is 3.5. On figure 3.3, sketch a graph to show the variation of force X with time t from t is equal to 0 to t is equal to 6 seconds. Since there is no change in momentum at after 4 seconds, that means there is no resultant force. So there will only be no resultant force if X becomes equal to the frictional force. So X is first 3.5 Newton till 4 seconds constantly. Then it increases to 2 Newton. Uh, suppose okay. Beaker in air contains a liquid. Base of the beaker is in contact with the liquid and has area A, as shown in figure 4.1. The liquid has density rho and fills the beaker to a depth of h meter. By using the definitions of pressure and density, show that pressure is equal to rho GH, where P is the pressure due to the liquid that is exerted on the base of the beaker and G is the acceleration of the ball. Okay, so we know that pressure, the basic base equation of pressure is force over area, right? Force over area. And now we need to calculate the force of this liquid on this space. So the force of the liquid will be W, weight, and the weight of the liquid is mass into gravity. Mass we can calculate from, it says that the liquid has density rho. So density is equal to mass over volume. So the volume of the liquid is basically base area into height. You can take this as a cylinder, this beaker. So the volume of the cylinder is basically base area into height. We can say that mass is equal to rho into area, base area, into height, which is h. So now we have the mass. We need to calculate the force. It's basically mass into gravity. So rho area, base area into height to gravity. And now we'll just put this force back to the equation of the pressure. So we get pressure is equal to rho A H G divided by base area. So area cancels out. So we get pressure is equal to rho G H. Hence, this is proven. Suggest why the equation in A does not give the total pressure on the base of the beaker. Because this beaker, this base does not only contain the pressure weight of this liquid only, right? It has a lot of air above it as well. So it's basically not taking into account the atmospheric pressure or the air pressure. There is air pressure. You can also call it atmospheric pressure too. Figure 4.2 shows the variation of the total pressure inside the liquid with depth x below the surface. So as the depth increases, so does the pressure. Determine the density of the liquid. So we know that this calculated that pressure is equal to rho GH, and it's saying with liquid with depth of x below the surface. So we can say that the change in pressure is also equal to change in h. Since if h increases, if x increases, so does the pressure. So Vg change in h. So rho we get as if we just take the change in pressure, which is 9.66 to 10 power 4 minus 9.60 10 power 4 divided by the change in h, which is basically 0 to 8 centimeter, but we need to take it into meters. So 8 into 10 power negative 2 into 9.81. And so we get rho as, calculating a second. 765 kg per meter. But since they are basically taking three significant figures, so we can just take it in three significant figures. Solid cylinder is held stationary by a wire so that the base of the cylinder is level with the surface of the liquid. The cylinder has length 4 into 10 power negative 2 meter, basically 0.4 centimeter, and cross-sectional area of this. Tension in the wire is 0.53 Newton, and the cylinder is now lowered and then held stationary by the wire. So the top of the cylinder is below the surface of the liquid. Calculate the new tension in the wire. Okay. So basically, uh, know that uh, the when the cylinder is resting on the surface of the liquid, there will be force of the it's called the uh, basically the upthrust. But since um, force equal to cylinder is now lowered and then held stationary by the wire, that the top of the cylinder is level with the surface of the liquid. First, acha, sorry. The top of this cylinder is level with the surface of the liquid, right? So basically, it's initially over here, and then it is brought down to over here. So there will be the upthrust on the cylinder. Sorry, I thought this was the final position. Basically, we need to calculate the upthrust, then we subtract it from tension. Upthrust is basically rho GV, and the, we calculate the density over just over here. Yeah, density is 765. So 765 into 9.81 into volume. Volume is cross-sectional area into height. 3.7 into 10 power negative 4. 4 into 10 power negative 2. That gives us around 0.11. Okay. Tension we now subtract from tension is now 0.53 minus 0.11, since it's in the supporting it, so we get 0.42. Okay. Question number 5. An electromagnetic wave in a vacuum has a wavelength of 8.4 into 10 power negative 6. State the name of the principal region of the electromagnetic spectrum for the wave. So basically, you need to know the varying frequencies of the um, if you only memorize the frequencies of different types of the electromagnetic waves, you can easily calculate, figure out which wave they are, since V is equal to F lambda. So you know that the velocity of all electromagnetic waves are 10 power 8, and if you divide that by lambda, so in this way you do not need to memorize both the frequency or the wavelength. You can just memorize one. So the frequency we get is 3.1 0.57 to the power 30. So if you like now check it from the table of those frequencies, okay, infrared is basically the wavelength of infrared is from 10 power negative 2 to 10 power negative 6. So since it's 10 power negative 6, we can say it's infrared. Yeah, I'll share the notes in the group, inshallah. Calculate the frequency in terahertz of the wave. So basically, we just going to do the same thing. We say V is equal to F lambda. Frequency is equal to 3 to 10 power 8 over 8.4 to 10 power negative 6. And so we get 3.6 to 10 power 13. And in terahertz, uh, we know that kilo is 10 power 3, mega is 10 power 6, giga is 10 power 9. Yep, I'll share the video for inshallah. And tera is 10 power 11. So we can say 3.6 into 100 or 10 power 12 to 10 into 10 power 12. So basically it becomes 36 terahertz. An arrangement that uses a double slit to demonstrate the interference of light from a laser is shown. The light from the laser has a wavelength of 6.2 to 10 power negative 7 and it is incident normally on the slits. Separation of the two slits is A. The slits and screen are parallel and separated by a distance of 2.8 meters. An interference pattern of bright fringes and dark fringes is formed on the screen. The distance on the screen across 8 bright fringes is 22 meters, as listed in figure 5.2. The light waves emerging from the two slits are coherent. So basically, there is interference happening. That what is meant by coherent? When two waves they have a constant phase difference, so it will remain like this. It won't happen like the wave is going through. It is constant over here. Then suddenly something changes and it becomes like this. And this actually happens in like headlights of cars and etc. So in coherent, we say that there is a constant phase difference between the waves. We also say in respect to time, or that it's not necessary. Calculate the separation of the sets. Basically, you need to know the formula, which is lambda is equal to ax over d. We know we have lambda and we have d, and we also have x, which is calculate x in moments. So we know that a is equal to lambda d over x. So what x is basically the fringe difference, right? So the bright. So basically this is x between two bright fringes. And they've told us that distance between 8 bright fringes is 22 meters. So what's the difference between two bright fringes? It's basically 22 divided by 8, which is 11/4 2.75 millimeter, but we need to convert this into meters. So we'll write lambda 6.2 into 10 power negative 7 d 2.8 meter, and x fringe width is 2.75 to 10 power negative 3. So the fringe slit separation is 6.3 to 10 power negative 4. Fringe P is the central bright fringe of the interference pattern in B. Fringe Q and fringe R are the nearest dark fringe and the nearest bright fringe respectively. The right of fringe P, as shown in figure 5. Okay, so this is the central, this is the dark fringe, and this is the next bright fringe. Calculate the difference in the distances from each slit to the center of fringe Q. So basically, they've asked us to calculate the path difference at Q. So we know that, let's say this is P. So the so if this is a bright fringe, that means that, so if let's say these are the two slits, right? These are the two slits. So if the wave goes from over here, they both meet at like the same point. They both amplitudes they add up to create the bright fringe. But over here, it's a bright fringe. That means that there is a path difference of negative 180 degrees. They are doing destructive interference. So that happens when there is a path difference of half a wavelength. Basically, half a wavelength apart. If you switch this to half wavelength forward, it will become same. So we say that it's basically 6.2 the wavelength square by 2, which gives us 6.3 into 10 power 3.1 into 10 power negative 7. Take the phase difference between the light waves meeting at the center of fringe R. Phase difference, since this is a bright fringe, but it's closer to this slit. So this let's say this wave completes 3 cycles. So this wave will complete 4 cycles, but they will meet at the same point. So basically, there's a phase difference of 360 degrees. Since there's a bright interference, so the amplitudes will align. Okay. A metal wire in a circuit has a length of, no, we can't write 0 because 0 means uh 0 means that uh, both of the waves are like travel the same distance. That's what 0 means, like both are traveling like same. In essence, the effect of both 0 or 360 will be the same, but in this situation, R is more closer to this slit than this slit. So when this wave reaches over here, this wave reaches 1 cycle later, but they both meet at the same point. So basically, there's a phase difference of 360, not 0. You understand? Okay. Yeah. Metal wire in a circuit has a length of 1.8 meter and a cross-sectional area of this. Total number of free electrons in the wire is this. There is a current in the wire, so that The charge of 172 coulombs moves past a fixed point in the wire in a time of 2.5 minutes. Show that the number density with the free electrons in the wire is 8.5. So number density is basically the volume divided by sorry, uh, number of charge carriers per volume. So it's basically a density, right? So volume is in the denominator, number of charge carriers. So number of charge carriers is 2.3 in 10 power 23. Volume we can calculate. Let's take the wire as a cylinder because wires are actually cylinders. So we have the cross-sectional area, basically base area into height. So cross-sectional area is 1.5 into 10 power negative 6, and the height basically is length 1.8. So we get 8.5 into 10 power 28. Calculate the average drift speed of the electrons. Drift speed is I is equal to nave. This is the drift speed. So drift speed is basically current over NAE, where this is the cross-sectional area, and E is the elementary charge, which is given in the paper. But we need to calculate the current. So we know that current is basically charge over time, and they're given us charge as well as the time. 2.5 minutes, how many seconds are those? 2.5 into 60, each minute is 60. So the current is basically 1 point. So the drift velocity 1.15 over 8.5 into 10 power 28 into 1.5 into 10 power negative 6, which is the area, into 1.9 elementary charge, 1.6 into 10 power negative 19. So that is 5.6 to 10 power negative 5. A battery of EMF 9.6 volt and negligible internal resistance is connected in series with two fixed resistors and a thermistor as shown. Okay, so these are all in series. The fixed resistors have resistances 3400 and 800 ohm. The reading on the voltmeter in the circuit is 6 volt. Calculate the current in the resistor of resistance 5800 ohm. So if in series we know that the voltage is distributed. So if these two they're getting 6 volts, that means this gets 9.6 minus 6, 3.6 volts. And we know that voltage is equal to current into this resistance. So the current is basically 6.2 into 10 power negative 4. Calculate the resistance of the thermistor. Okay. So we know that the resistance, it adds up. So we can say V is equal to IR. You know, these two get 6 volts. The current we just calculated. And the resistance is basically 3400 plus the resistance of the thermistor, which we need to calculate. So we can say 3400 plus R is equal to 6 over 6.2 into 10 power negative 4, which is so the R we get is 277, or you can say 6.3 in 10 power. Oh, you can say they've given everything in two significant figures, so let's stick to two. The initial energy stored in the battery is this. Assume that the EMF of the battery is constant. Determine the final energy stored in the battery after a charge of 330 coulombs has moved through it. So we know that power, or basically potential difference, basically the work done over time, right? So uh, sorry, work done over charge, sorry. So the work done is basically voltage into charge, 330, so which is 3170. So this is the amount of work done. So the final energy is basically initial energy minus the energy used in doing work. So we get 2.3 10 power 4 joules. The environmental conditions change, causing an increase in the resistance of the thermistor. State whether there is a decrease, increase, or change to the temperature of the thermistor. The graph of thermistor and resistance, basically an inverse graph. So as the temperature increases, the resistance decreases. So if there is an increase in the resistance, that means there's a decrease in temperature. Temperature decreases. Current in the thermistor. Since resistance is increasing, so V is equal to IR. V is constant. I is equal to V over R. So resistance increases, current decreases. The potential difference across the thermistor. V, since we take V is equal to IR again, but we don't need this. We know that the voltage is constant, right? Like let's say it's basically let's hypothetically say the current remains the same. So if it's getting 6 volts right now because of its resistance, but if you increase the resistance, that means that you decrease the current, right? So if you basically decreasing the current, that means that more resistance is equal to is getting basically more voltage. That's why the resistance increases, current decreases, and the voltage it increases. An isolated stationary nucleus X decays by emitting an alpha particle to form a nucleus Y. Nucleus Y and nucleus Z are isotopes of the same element. Okay, so basically they have the same proton number, but different neutron. By comparing the number of protons in each nucleus, state and explain whether the charge of nucleus Y is less than, greater than, or the same as the charge of nucleus. So you know that X decays by emitting an alpha particle. What is alpha particle? Alpha particle is basically an helium nucleus. So it has 2 neutrons and 2 protons. So it basically lost 2 protons. So that means that its charge, and since it's asking of Y, if they are isotopes, but so they have equal number of protons, so it's just they have the same charge for nucleus X, nucleus Z, since they have the same proton number. But for nucleus X, their charge will decrease since they have less protons. For protons, so less charge. Use the principle of conservation of momentum to explain why nucleus Y cannot be stationary immediately after the decay of nucleus X. So basically, what's saying here is it says that X is stationary, and let's say this is X. X is stationary, so it has 0. And then it converts to Y, and let's say it explodes and it shoots some alpha particle. Let's say it has a speed of, let's have speed of X meters per second. So we know that initial momentum, like uh, the conservation of momentum, which means that initial momentum is equal to final momentum. So the initial momentum is 0, and final momentum, we say that A, whatever its mass is, which is 4 atomic mass units for U into X. So the only way for this to be 0 plus the momentum of Y, this Y cannot be 0, right? If Y is stationary, that means that whatever the mass of Y is, we take it as Y, my into 0. But 0 is not equal to 4u into positive momentum. So that means that it has to have some negative velocity which counters this. So basically Y is emitted in this direction. So this velocity, this momentum is countered by this momentum to like equate the equation which means initial momentum is equal to final momentum. So we write momentum before decay is 0. So total momentum after decay must be 0. Hence, Y must have equal and opposite momentum to the alpha particle. I think I didn't explain this part. I think I should explain this part again. The potential difference across the thermistor and the resistance of the thermistor increases, will increase since we know that the potential difference it receives is basically the ratio of the resistance of resistor over the total resistance into the electromotive force or voltage terminal potential difference. So we calculated it 6.3 into 10 power 7. Let's say we call that X. So and this total resistance, it remains as 3400 to 5800 plus its resistance. So if we increase x, that means that this ratio will also increase, right? So it will get more of the potential difference, hence its potential difference will increase. Hopefully you understand it now.